This is problem 6-9. So part A is actually really easy because they already give you the period. This is the period, and this is the period times 10. So to get the second column, which is t, which is a period, all you have to do is actually divide this number by 10. So you move the decimal places back by 2. So yeah, these are all your answers. That's actually fairly easy. And this is also fairly easy. You just take this number and you square it. So all of these, such as this one, is just the square of this one. And then for the graph, I won't be drawing the graph out, I guess, but you basically just take these points, since they tell you your axis, so you just take the L and you graph it by t squared. So for example, you would take 12, and then you would graph, this would be on the x-axis, and then you would graph this on the y-axis. And then after you graph all 4 of these points, you're going to draw a linear line, so your graph is going to look something like this. It's going to be linear. And then you're going to have points around it. Like that. But yeah, that's just an approximation. And then for part C, you're going to be needing to find the slope. And the slope is just going to be equal to the change in t squared, or change in L. Now through your equation, on the equation sheet, t equals 2 pi times the square root of L over G. And you want to find slope. So you're going to square both sides, you're going to get t squared, and then you're going to divide, or this is going to equal to 4 pi squared, and then this squared is just going to be L divided by G. So, and then this, if you divide this by L, you're going to get the slope. So let's say you bring the L over here, then you're just going to have slope equals 4 pi squared over G. This is going to be your experimental G. And then your slope is going to be the slope that you're going to get from the graph, which you should have learned in your calculus classes. And then the slope is going to be approximately 4.5. So if you plug in 4.5, then your G experimental should approximately come out to 8.77. This is all just approximation though, so your answers can vary, but it should be around these values. So we're not going to need this chart anymore. For part D, this is just calculating your percent error. So your original gravity should be 9.8. And then to calculate the experimental error, you just do 9.8 minus whatever the value you got from part C was, which in this case we're just going to do the estimated number, which was 8.77. And then you're going to divide that by your experimental number, 8.77 times 100, because that will give you the percent. This should approximately come out to be probably 11.7%. But then again, that's all just approximation, so as long as it's around this value. And this is going, 11.7 is greater than 4%. So it's not a really acceptable value, but then again, that's what the answer is supposed to be like. And then for part E, you're going to be using Newton's second law, F equals ma. Kind of random in the problem, but yeah. All the forces acting on it is going to be mg minus normal force, and that's going to equal ma. In this case, n is going to be equal to mg, and the g is going to be your experimental g value. So actually you can divide both sides by m, and you're going to end up with acceleration will be equal to g minus the g experimental value. So just plug those numbers in to find a, where so a is going to equal 9.8, because that's the original g, minus the experimental value, which is of course your experimental value. In this case, we're going to have 8.77, and that'll come out to be approximately 1.03. Yay, we're done.
Okay.